So it says record lesson. Everybody got I gave everybody a copy, yes? Henry, just send it somewhere where that looks empty, and if there's no empty area, kind of just pass it to the front and I'll grab it. Thank you. The non-physics definition of momentum, it's the amount of motion an object has. It's the amount of motion an object has. Mr. Dueck has finally snapped. You've suspected it for a while. You've seen the tick, 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 tick underneath the surface. Chase was late, and Mr. Dueck is going to throw something at his face. I'm not really going to throw something at your face, but really an object lesson. So let's suppose Mr. Dueck, in his craziness, decides he's going to lob a tennis ball at Chase's face. If I underhand gently lob a tennis ball at Chase's face, how nervous is he about that? On a scale of 1 to 10, 10 being I've got the 9 and the 1 dialed already, 1 being whatever, probably about a 2. In fact, he may even, just as a show of toughness, take the tennis ball on the face and just pretend like nothing. As opposed to, what if I got into a full Major League Baseball pitcher stance and I overhand threw it straight at Chase's face and he wasn't allowed to dodge? Would he be more nervous or less nervous than if I underhand lobbed? It'd be fairly obvious, folks. So here's my question. What's the difference in terms of physics terms between underhand lob and throwing it as hard as I can? Which variable do you think is going to show up in our momentum equation? Drop the I. Velocity. Okay? There's going to be a V in our equation, absolutely. Underhand lob, Chase of me. Overhand throw, Chase might die. Oh, but hey, Mr. Dueck's really gone cray-cray. He looks around, he can't find his tennis ball, but what he does happen to find is his handy-dandy bowling ball. So now, but Mr. Dueck can't really throw this overhand, but he can lob this. If I were to lob this at Chase's face, more nervous or less nervous than lobbing the tennis ball? What other variable do you think should appear in our equation? There. So I'm going to argue the concept and the physics behind momentum is kind of obvious. How much motion an object has depends on how fast and how big. The worst ones are objects that have a huge mass and a huge velocity. And I have to be negative here. The World Trade Towers that were hit by airplanes, by jets, you can run the numbers of those jets' masses with fuel and their velocity. There was plenty of momentum. Sorry, conspiracy nuts. There was plenty of momentum to take down the World Trade Center towers. In fact, it's a surprise that they stood up as long as they did on that terrible day. And the even worse ones than that, asteroids. Asteroids. We had a huge one hit about 400 million years ago that wiped out the dinosaurs and did cataclysmic damage. There's no rule that says somehow Earth is protected. You might recall in the news around Christmas time, a new asteroid had been discovered that at that time had I think a 2% chance of hitting the Earth in a few years. And I'm sure you've all heard about Apophis, the football stadium-sized asteroid that's due to hit us, and this is true, Friday the 13th in 2029, on a Friday the 13th. I'm sure you've heard about that one too, right? You haven't heard about Apophis? Take Physics 12. We'll look at asteroid impacts. Yeah, probably, potentially off the coast of California in the ocean. It would make a tsunami really big. It would wipe out most of the west coast of North America if it hits us. Right now, the percentages are constantly dwindling as we get better and better data, but great name for the asteroid, Apophis, the Greek god of death and darkness. When you spot an asteroid that might hit the Earth, right, you don't call it Bambi. You know, give it a name, right? Okay, so, and Chase, of course, I was never really going to throw something at you, but all of you intuitively were able to say, I think I know what momentum depends on. It depends on mass and velocity. So example 1 says, for each of the diagrams below, state whether the amount of motion, of momentum, is comparatively large or small. Small mass, small velocity. You know what? Underhand lobbing a ping pong ball. I'm willing to bet most of you, if the ping pong ball was underhand lobbed towards your face, you might do a calculation and say, it's less work to let it hit me than it is to try and dodge it. I'm just going to let it hit me because I know nothing. So we would say very small. Yes? What about a small object moving faster? This would be more of a medium amount of motion. Now, there's a limit because, Henry, what about a bullet? That's a small object moving really, really fast. So if I get something going really fast, I can get it to have a fair bit of momentum. But here, we're just saying like someone throwing a human being throwing a ball. Here, bowling ball at a slow speed. Well, this is larger, but still not the worst. The worst would be big speed, big mass. So I talked about the jets that hit the World Trade Center. I talked about asteroid impact. Here's one all of you have seen in the movies, a locomotive. All of you, at least once in a movie, have seen a locomotive hit a car. That's a classic movie trope now. They love to do that stuff. And if you remember seeing it, you might recall the car accelerated pretty fast and got out of the way. Locomotive, hardly phased. Why? Big mass, big speed, lots of momentum. Yes? Train. Yeah, the front part of the train, because the rest of the train's getting dragged. The locomotive is the engine part that's pulling everything forwards. Okay? We learn a new word. Sesame Street is brought to you today by the word locomotive and the number pi. Okay. It says explain your answer. Zainab, I'm going to argue. We just kind of figured it out. Okay. So as an equation, momentum is mass times velocity, and I'm going to bring back the vector arrows. We're really going to have to pay attention to direction again. We're going to have to get in the habit of letting one way be positive and one way be. We're going to get in the habit of letting up be positive and down be, or forward be positive and backward be, or north be positive and south be. Or you can flip it if it makes the math, if it makes the math easier, you can let down be positive and up be negative. But when we're talking about collisions, a head-on collision is much worse than a rear-end collision, and that's because direction matters. So momentum is mass times velocity. What would be a good abbrev to use for momentum? Why can't we use M for momentum? Already taken. So because you were multiplying two numbers together, when you multiply numbers, it's called a product. We use a lowercase letter p. It's the motion product, and it has a direction. Momentum has both magnitude and direction. Can you all find that equation on your formula sheet so you know what section we're in now? Y'all found it there? Okay. Turn your formula sheet over, look at the bottom of the page. I lied. This is only correct when we're not going near the speed of light. At the bottom of the back page, you'll see a P equals equation that has that Einstein-Lorentz expression, that square root thing. That's technically the correct equation, but we're not going to be going anywhere near the speed of light, so you can turn the back to the front page. We're going to use momentum as mass times velocity. Maddie, is it on your formula sheet? Say yes. Do you need to memorize it? I would out of laziness during this unit. You might out of laziness consider remembering that P equals mv, momentum is mass times velocity, because you're going to get sick of looking it up. Oh, also, how many variables are there in this equation? 3. So look at that equation. Get the v by itself, Afan. I can give you the momentum and the mass and say how fast does it need to travel to get that momentum. Get the m by itself, Clara. Be okay with that? You don't need to write down both of those versions. I think we've accomplished with our formula manipulation, Peyton, the ability to look at an equation and see all the other equations hidden inside of it. Yeah. What would the units be? It's in the equation. It's in the equation. Carly, it's mass times velocity. What are the units for mass? Kilograms. What are the units for velocity? So momentum is kilogram meters per second. It's a bit of a mouthful to say. They've talked about renaming this. For example, who remembers from last unit, F equals what? Which means although force is measured in newtons, it's also measured in kilogram meters per second squared. It's MA. And about 80 years ago, there's an international committee that decided to rename that a Newton. They're talking about renaming this one an Einstein, and that might happen in your lifetime, but they've been talking about that for about 20-ish years. And it's a slow committee, as it should be. You should be very meticulous and take your time before you start mucking around with units in science, because you never know the domino effect it might have. But they're talking about renaming that. For now, momentum, you can see it right from the equation. If you ever blank out to mana, it's kilogram meters per second. It has to be. It's mass times velocity. Ooh, actually, that's a bit of a fib. Tristan, there's another way to write momentum. I wrote here, a Newton second is also momentum. Really? Everybody write down Newton second. And we're going to break this up. Newton is force. Kobe, F equals what? So M, kilograms. A, meters per second squared. Chase, this was stuff we did before Christmas, before you got here, if you're wondering how they all knew it. We really drummed this in. Seconds, that's a Newton second. Lucas, do you see it? How many S's are there on the top of this now? How many S's are there in the bottom of this fraction? This S right here cancels out with the squared, and left behind is kilogram meters per second. A Newton second is the same as a kilogram meter per second. They're interchangeable. Some textbooks use this. I'm going to use this in certain, come on, pen. I'm going to use kilogram meters per second in certain situations, but you're going to see in a couple of days, there will come a time when I use Newton seconds, and spoiler alert, it'll be because I have an F and a T in the equation. I have a force and a time, and so it's just easier for me to translate the units as Newton seconds. Momentum is kilogram meters per second, but it turns out a Newton second works out to the same thing. Next page. Because I'm introducing a brand new concept, momentum, to you, I always like to give you an idea of what's really big and what's really small. So I've turned the page. I'm going to write momentum equals mass times velocity. You have it on the previous page, and you have it on your formula sheet, so you don't need to write that if you don't want to. But you are going to need to get your calculators out in just a second. It says estimate the magnitude, so we don't care about the direction. I'm not going to include a north, south, east, west. Estimate the magnitude of the momentum of a top pitcher's fastball. Any baseball players here? Anybody used to play baseball? Competitive baseball. Okay, Henry, what does a baseball weigh in kilograms? I didn't either. So I happen to have here a 1 kilogram mass. Hold your hand out. Ready? Heavy. Ready? It's heavy. Is the baseball heavier or lighter than that? Definitely less than 1 kilogram. What do you think? My guess is about a quarter of that-ish. That's really a ballpark, but I kind of sat like this and I said, yeah, I think even less than half of this. So let's say M is 0.25. So estimate mass, let's say M equals 0.25 kilograms. Speed. If you watch, and it does say top pitcher, yes? If you watch Major League Baseball, Henry, what are the top pitchers in the pros hit? Once in a while, it's a nice round number in miles per hour. 100 miles per hour, a few of them can get that. What is that in meters per second? 100 miles per hour in meters per second, it's around 44, you know what, we're doing estimating and rough numbers. I'm going to say it's around 50 meters per second. That's actually about 108, so maybe a little faster than even the best of them can get, but we're estimating. What's the momentum? Multiply it out on your calculator. 0.25 times 50. How much momentum is that? I think it's 12.5. Yeah, it should be. Yeah. Units. It's in the equation. Units. Kilogram meters per second. So 12.5 kilogram meters per second. If you are a human being standing in front of a baseball pitcher and they beam you in the torso at this speed, are you dead? No. Are you going to the hospital? As long as they don't hit you in the head, probably not. This much momentum, if you had to absorb it, you're going to say some bad words. You're going to be owie, 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 but we're not calling 911 and we're not calling the morgue. In other words, if you're wondering, really anything less than 100 kilogram meters per second squared, all of you could absorb that in a collision, and you might drop an F-bomb, but you'd be okay. Now, there's a lot of variables. If it hit you right on the side of the skull, totally different matter. But basically, if it's hitting you in the rib cage and the torso, you can absorb a couple of 100 kilogram meters per second without permanent damage. Peyton, what's the second thing it wants me to estimate the magnitude of the momentum of? Okay, let's get the mass. Oh, and it says on a relaxed ride, so we'll have to figure out a good guess for a speed on a relaxed ride. Bike and rider, kilograms. You know what? 100 kilograms would be about 230 pounds, which is a little high. I'm going to go, because we're estimating and I'm picking nice round numbers. Let's say M equals 75 kilograms, because it's the bike and the rider combined. All right, let's see if we can figure out the speed. Probably for you folks, we'll figure out the speed in kilometers per hour, and then we'll use that 3.6 to convert it. Do bikers on a relaxed ride, do they do 50 kilometers per hour, the same as cars on city streets? No. Okay, so smaller than that. Do they do 30 kilometers per hour, the same as the speed in a school zone? I think they're a little slower than that. So I'm going to say maybe 20 kilometers per hour. Can somebody, all of you, on your calculator convert that? It has something to do with the 3.6. 20 kilometers per hour, what is that in meters per second? 5.5? I'm going to, because we're just doing some rough rounding, I'm going to say, how about 5 meters per second? Doesn't matter. This is way estimating. I'm rounding, so Dom said, aren't we rounding up? I'm rounding nice is what I'm rounding, which is just keeping the numbers good. By the way, Dom, my class, this way, in my classroom, that's around 5 or 6 meters. Biking that in 1 second, yeah, that's fairly relaxed. You're not standing and pumping it on the pedals. So I think we're close. Plus or minus, we're close. What do you get? 75 times 5. Sorry? You get something in the mid-hundreds or higher. Yeah, 375. If you got hit by several hundred kilogram meters per second, this is probably the injury stage. Oh, my finger is pointing out at a 90-degree angle. I dislocated a finger. Oh, my arm is dangling. I broke my arm. But we're not calling the morgue, probably. We're calling an ambulance, probably. Most of you could absorb 600, 700, 800 kilogram meters per second. Some of you more. Okay. If you get hit by a car, what are you thinking? Okay, what's the mass of a car? Nice round number. I'm going to guess 1,000 kilograms, maybe more, but... And I think it says the speed on a city street, does it not? What's the speed limit in kilometers per hour on city roads? So can you convert 50 kilometers per hour to meters per second? It was something to do with the 3.6. You all have it on your formula sheet somewhere. Sorry? I'm going to round nice. 15. 15. I'm using 5s whenever possible. Also because everyone speeds a little bit, right? Also, I bet you don't even need a calculator for this, Maddie. What would 1,000 times 15 or 15 times 1,000 in your head with, really? 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 Tamanna, you did it in your head, right? Right. Mm-hmm. Kilogram meters per second. If you're absorbing something in the tens of thousands, 20,000, 30,000, 40,000, and again, lots of variables, but probably the only phone call that you're making is there anybody you'd like to call in the next 30 seconds? Because, right? There's again, lots of variables. Certainly, if you're absorbing several 100,000, not a chance. Not a chance. Padding would make a difference. Football players, a good NFL linebacker, when they really hammer someone, they're around 10,000 kilogram meters per second. But because the person that they're hitting is also wearing padding, they're again not dialing 911 or calling an ambulance or it's so there, again, lots of variables, but just to give you an idea. Example two, I like example two, I like example two. Example two is a nice question. So let's go back to me throwing something at Chase's face, because you're all thinking it. A baseball of mass. Oh, Henry, I forgot. I had looked up the mass. We said 0.25, 0.14. That's pretty close enough. Okay. 0.14 kilograms is moving at 35 meters per second due south. Henry, what does A want me to find? Keep reading. And direction. So I'm going to give them a magnitude and I'm going to give them a direction. I think in this case in terms of north, south, east, or west. What's the equation for momentum? Yep. So it's going to be 0.14. This might work out to a nice number. Times 35. What do you get? 4.9, I think. Double check me. Or 9. Is it 4.9? Units. Kilogram meters per second. Direction. Read the question. Direction. Okay, now look up, don't write this down. Look up, don't write this down. Why can't I just write that for south? So, how do we show we're writing a direction? There are two ways. Some textbooks will put things in square brackets, and that's perfectly acceptable, but that requires writing 2 characters, and I'm lazy. The other way is you use an at symbol, and you put the direction after the at symbol. I do that because I'd rather write 1 character than 2 characters. I'm that lazy, but organized. This is really important for north, because what letter would you use as your abbrev for north? A capital letter what? And newtons, and some textbooks use that for normal force. There's a reason why I never use that for normal force. The worst one, you're going to run into this later this year and in Physics 12, is W. What direction is W? It's also work as a physics concept. It's also watts as a unit. Thank God it's not a metric prefix, because if it was also a metric prefix, it would be showing up in one question in 4 different locations. So it was up in 3 different locations sometimes. All right, I want to hit Chase in the face with 4.9 kilogram meters per second, but I can't find a baseball. All I can find is that stupid bowling ball. Chase, what does B want me to find? Magnitude and direction at which a bowling ball, mass 7.28 kilograms, would have the same momentum as the baseball. Let's write down our momentum equation. Momentum equals mass times velocity. By the way, this now is our 5th or 6th way to find the velocity, so you have to look at the context, Claire. If I saw a VI and I saw a T, I'd be going stuff from before Christmas. But as soon as I saw momentum, I went with that. Okay. Chase, I want to get the V by itself. What's the M doing to the V? Adding, subtracting, multiplying it? How will I move the M over then? What's the opposite of times? So you're telling me, and you don't need to write this, you can derive it in your head, velocity is momentum divided by the mass? Yes, it is. What was the momentum? 4.9. What was the mass in this question? 7.26. If I want Chase to feel the same owie from a bowling ball as the baseball traveling at 35 meters per second. By the way, 35 meters per second, about 70 miles per hour. That's the speed of a good high school pitcher. Most of you could not throw a baseball that fast. 7.28. Is that what you're going to say, Peyton? It's not 2.6, it's 2.8. I read the number wrong. I don't think this will work out even. What do you get? Oh, by the way, would I have to throw a bowling ball faster or slower to make Chase hurt as much as a baseball? Be stupid obvious. Slower. Got more mass, I can throw it slower. You better get an answer less than 35. Yes? What'd you get? Yeah, what'd you get? 0.67 what? Give me 3 sig figs. 0.673 meters per second. Okay. Does that make sense? A heavier object traveling slower towards Chase's face would be the same, ow, as a smaller object traveling faster. And again, what are the worst ones? Oh, this is why Cannonball does so much damage. Big mass, big speed, get out of the way, right? Example 3. Turn the page. Mr. Dueck, yes, Chase. Are you done throwing stuff at me? I'm done throwing stuff at you in this unit. Yes, you can relax now. In this lesson, at least. What has more momentum? A logging truck at rest or a ping pong ball rolling across the floor? Why must the ping pong ball have more momentum? How much momentum exactly as a number does a logging truck at rest have? It's at rest. So don't just look at the mass and velocity. So what has more momentum? Because it's got some velocity. Example 4. Example 4 isn't as much nasty as it's going to be some extra steps. Back before Flex came around in 2017, we're on year 8 of Flex. Before then, because when Flex came in, I lost some instructional time, I always did a final exam at the end of the year. And what I started doing in this unit was sneakily reviewing as much of the previous units as I could. This is going to be some review from some stuff from before Christmas. So Chase, that's for you. This might sound like gobbledygook to you because you joined us after Christmas, but for the rest of you, we're brushing the cobwebs off. Okay, Tristan, what's example 4 asking me to find? Yeah, let's read the whole thing. It says, a 12-kilogram rock is dropped. You know what? We used to underline the word dropped because that used to tell us something. From a 75-meter high cliff. What does it want us to find? Keep reading. For direction, how about let's let up be positive and down be? Have you figured out your line for a while? Yeah? Okay. So I'm going to say momentum is mass times velocity. Oh, this is easy. Oh, why did I just come to a grinding stop? Okay. Even though this question is saying find the momentum, you know what I'm going to spend most of my time finding? Velocity. So I'm going to draw a little line like that, and I'm going to walk over here, and I'm going to go, okay, V equals question mark. What does dropped tell me? You know what? As soon as I wrote VI equals 0, I walked back and I put an F under the... I said, I bet you that V is V final. Yes? What else do I know? What's that 75? I'll give you a hint. Technically, it's nothing. I'm not going to use a 75. What am I actually going to use? It needs to be a displacement. So I have to make it negative because we are ending up below from where we started. I have to say D equals negative 75. Remember kinematics, which now seems so nice. Back then it seemed tough. You heard me say things like, I need three things to find the fourth. Right now I only have 2 things, VI and displacement. What else do I know? What is the acceleration? Now we're back to our vector negative. We ditched that in forces because you noticed it was easier to let the winner be positive, especially when 2 objects were moving in different directions. Who cared? Here, we're going to be a bit more meticulous again. So I'm going to say A equals negative 9.8. Tristan, I'm looking for an equation that's got a VF, a VI, a D, and an A in it. There is one. All of you want to go back and look to jog your memories, right? Why'd you waste my time? What could you have read, Tristan? VF squared, you could have skipped the VI squared since it's 0, and you could have just said 2AD. We were good at that back then. We're brushing cobwebs off, and I'm fine with that. Oh, and then we would have said, I want to get the VF by itself. And you might have said, it already is. And I would have said, well, no, there's a squared. How does one get rid of a squared? One wonders. And you would have, good. This was where I really started to sell you on the value of getting comfortable with formula manipulation. It cuts your thinking down. Well, your memorization. So it's going to be 2 times negative 75 times negative 9.8. All of you want to try typing this into your calculator. If you don't know where your square root button is, I'll show you after the lesson if you've forgotten. What'd you get? That can't be right. Oh, this was that weird situation. We said, what's the square root of 9? It's technically plus or minus 3. Your calculator always assumes you want the positive answer by default. Tamanna, this time, what direction are we traveling? Starts with letter D. So this time, do we want the positive answer or the negative answer? Yeah, it's going to be negative 38.3 meters per second. And I'm going to walk that over to here. I'll show that with an arrow. So the momentum is going to be, what was the mass, Mr. Dueck? 12. Mr. Dueck, how would you type that on your calculator? I would go like this, negative button, and then my answer button. That's the least number of keystrokes and the most accuracy and the least chance of a typo. So I'm going to go 12 times negative answer button. I got negative 460. Yes? Where does that fit on our lethality scale? Oh, first of all, direction. I already included it with the negative. I would also take 460 kilogram meters per second down. I would live with that. I would not take negative down, because I would argue, technically, what's negative down? I would argue that's up. So don't use double negatives. I think I said something like don't not use double negatives, because it's confusing. You can use either of those. Most of you settled on this one because it was less writing than writing out the word down. Where is this on our lethality scale? Kill ya? So let's get dramatic. Replace the 12 kilogram mass with a toddler on a deck. All of you could catch this. You might get some injury, but you could rush in and you could catch that toddler and save a life. Replace that with me on a deck. All of you would say, sorry, Mr. Dueck, better hang on till the firemen get here, because there's no way I'm trying to catch you from that height. Now, yeah, because probably if you run the numbers with my mass and that velocity, now it's tipping over into the, yeah, boy, better have the 9 and the 1 ready to go, and maybe the last person you want to talk to ready to go. Okay? So, momentum is what times what? Mass times velocity. It's a vector. We're going to start paying attention to directions more. It has 3 things. If you know any 2, you can find the third. You can often rewrite this equation in your head. It's on your formula sheet, worth memorizing just during this unit out of laziness. What's your homework? Every question. I was hoping to give you a bit... sorry, I didn't want to do that, Mr. Dueck. I was hoping to give you a bit more time, but you have about 7 minutes. Let me hit pause.